Hi there. In this video we're going to see how to deploy NAT on ASA, and we're going to meet a couple of requirements that I have defined, and we're going to start with allowing DMZ server to reach what I consider the internet side, the outside interface, to a public IP address, and then we're going to allow this network 10.1.2 to be translated to the outside interface of the firewall. And another requirement will be to allow 10.1.5 network, where supplicant 3 is located, to be translated to a range of IP, to a pool of public IP address. And lastly, we're going to allow that R5 and R6 to be reached via same IP 111.12.100 on different ports. This is also called as port forwarding. So whenever I try to telnet to 111.12.100 on port 235, is going to be redirected to telnet on R5, and when I try to 111.12.100 on port 236, it's going to be redirected to telnet on R6. And we're going to test this one using the PCs that we have on the topology. So let's begin. I have ASA blank right now. The only thing I changed is the host name. Show interface IP brief. So let's start with outside and then DMZ and the inside interface. I think it will be easier to move in this direction. So the outside interface, we're going to enable it, chat, and assign the IP 112.1.255.55.4. Just confirm reachability with R1 working, and I have BGP with enabled on R1, so let me enable that as well. So if I call remote, it's 1, and I'm going to enable this process. Now I have interface G02 as my DMZ interface. Name it DMZ. No shots. I'm going to increase the security level to 50 and assign the IP 10.1.11.1, and this is /24. Let me test reachability to R3. Works as well. And now I need to reach DMZ server, my web server. So for that, I'm going to add a static route located at DMZ, and the IP is 101.10.2.1, and I should reach you via router 3. So if I test now, that's okay. Okay, so let's start by meeting the first requirement, and this to allow DMZ server to reach outside interface with this static IP address. So it's going to be a static IP 101. So for that, we're going to create an object. I'll name it 101.10.2.1. Now say host 101.10.2.1, and again, my NAT rule is going to be from DMZ to outside. Make it static to IP, and it's got to be 101.12.101. Okay, let me confirm that. And can confirm my NAT rule as well. So without applying any ACL, right now this traffic should be allowed just based on the level of trustworthiness between the interfaces. So right now, DMZ interface has a security level higher than outside, so this is going to be allowed as the flow works from more trusted interfaces to less trusted interfaces. So if we have traffic that is initiating from the outside, won't be allowed towards DMZ or another interface with a higher security level. So let's test these from DMZ server, and I have HTTP running on R1, so we can test these by trying to reach 1111 on port 80, and it's working. And we can confirm that by looking at our NAT translation table, and you can see this is the IP of web server. This is being translated to 11.12.101. Okay, so the first one is done. So now let's look at inside, and we have to allow 10.1.2 to be translated to the outside interface of the firewall. So for that, let me enable my inside interface. Security level is going to be 100. Enable that and assign the IP 10.1.91.255.255. This is /24, and I have OSPF running on R4 with authentication. So first I'm going to enable it, and it's going to be message digest and message key MD5. It's CCIE 65745. Now let me enable the process, so it's going to be 10.1.91. I'm going to enable just on that interface area 0, and I'm going to inject a default route as long as I have a default route coming from BGP. Oh, sorry. Yes, and if I look at my routing table, that's okay. And show SPF neighbor, it is established, show route SPF, and I have. So now I can reach my internal networks, and they should be able to reach the firewall as well. Now let's create the NAT rule, and I'm going to create an object for that. Now name it 10.120.24, and this is a subnet, and 120/24, and NAT is going to be from inside interface to outside interface, and this is going to be a dynamic and should use the outside interface of the firewall. So we can confirm that. Okay. And let's test from N1, from Win15, this one. Let's try to open a page that is located on R1 11, and I'm able to open the page 6CI645. Yeah, so it's working, and I can confirm this looking at the logs as well. So I can see that 10.121 has been translated to 11.12.1. Okay, so second requirement, it's okay. Now let's move to the next one, and this is going to be from 10.1.5 to be translated to a pool of addresses. Okay, so let's start by creating the internal object. So that's going to be network 10.1.5.0.24, and the subnet is 10.1.5.0. 255.255.0. And for that, actually, I have to start with the range object. So I'll get back to this in a moment. So first we need the range, and that's going to be 1112.50 to, let's say 59. And that's the range object. It's 1112.59 to 1112. Sorry, 50 to 1112.59. And that's it. And now back to previous object 10.15. Say NAT from inside to outside. I want to dynamically be translated to this object. So you can see that we can specify the IP or an object, and right now I'm going to use this object. So run NAT, and we see that this object is going to use this pool of addresses. So now let's log in on supplicant 3 and test these. And that should be HTTP 11 and that was successful as well. That's PCIe 745. Taking some time, it's thinking. So if we look 10.15.100, you see that it is using one of the IPs. Let's just refresh this. For some reason it fails, and it's working, and it's being translated from one of the IPs in the range from 50 to 59. Now the last requirement, we're going to create the objects for R5 and R6. And there is one difference as compared to these other requirements, is that we're going to test these from the outside interface. And as I said previously, traffic initiated from less trusted interfaces to most trusted interfaces or to most trusted zones is not allowed by default. So to allow this traffic, we will have to create an ACL and apply the ACL at the interface. So first let's start by creating the object. Okay, so this is going to be host 555. I'll say host 5555. It's going to be translated from inside to outside, and that's going to be static to IP 1112.100, and I have to say what is the service TCP, and internally it's 23, but at the outside you'll be seen as 235. I'm going to do the same for 6666. Is it? Yes. Just change. I'll say host 6666 and that change here to 236. It's going to overlap as just a warning. I can see if the object was created. Here 555 and 666. So run NAT. So before even testing, we can use packet tracer tool to validate whether this traffic is going to be allowed or not. So we call packet tracer input from outside interface. That's the service from 1112 on a random port destined to 555 on port 235, or we can even say on port on the IP 12100 on 235. So it is going to be untranslated, okay, but it's going to be dropped by an implicit rule. So let's solve it by creating an ACL. Now this ACL is going to be applied at the interface. So first, what I want to ensure is that my BGP session isn't affected. So I create an access list and I'll say outside to inside, and I want to permit so let's say from 1112.0 55550 to 1112.0 55550. This list can be extended. What am I missing? Oh, permit IP. Okay. Now I'm going to add another rule, and that's going to be permit TCP from host 1112 to now we have to say what is the real IP 5555 on port 23, and we're going to do the same for 6. Now we have to apply this ACL at the inside direction of outside interface. You do this by running access group ACL name that we want to apply at inbound direction of outside interface. Done. So now let's test the flow once more, and we see that it is going to match. We're going to hit the NAT rule we have in place for the host R5, and this is going to be allowed. It's going to match our ACL as well at the inbound outside interface, and it's going to match our ACL sourcing from 1112 destined to R5 on telnet, and we see that it is going to be successful. So an additional tool that we can use for validation or for troubleshooting is to enable logging at the console level, or if you're using NAT or SSH. And as this is a lab environment, I'm going to enable at the console debugging. And I have to test this from remote worker, and I should be able to telnet to 1112.100 at port 235, and I am at R5 console. You can see with my IP 111.112, and if I want, I should be able to get to R6 as well. We can confirm this with the logs. We have an inbound connection sourcing from 1112, ours R5, and same for R6. Okay, if we want, we could use different options. For instance, we could make a remote worker to appear to R5 and R6 like it was an internal IP of any range. We could do this just by adding another object and applying it at the outside interface. So different variations to meet different requirements, and ASA gives us a lot of flexibility when it comes to NAT, and if we use it cautiously, it can be very handy. So that's it, guys. That's what I want to share with you, and I'll see you in the next one.